The broadcast is now starting. All attendees are in listen-only mode.
Okay, let's get started. Good morning, good afternoon, and good evening, everybody. My name is Filip Černý. I'm Product Marketing Manager at Progress. And today we're going to look at our webinar called Beyond the Bucket, how Flowmon's flow technology enhances network and security operations. Before we jump into the webinar, let me just cover quickly some housekeeping rules. So this webinar is being recorded, so you will receive a link with the recording in the follow-up email. Throughout the webinar, if you have any questions, don't hesitate to use your navigation panel. So you can submit your questions throughout the webinar anytime. We do have some dedicated time for the questions at the end of the webinar. For those questions that we won't have time to answer, we will answer in the follow-up email as well. If you have trouble hearing us, try switching to your phone audio instead. And with that, I hope we covered everything. We can dive right into the topic. So if we look at the network and IT operations today, we see that IT teams are facing never-ending challenges, from root cause analysis, troubleshooting any issues, differentiating between operational issues and performance, monitoring the bandwidth, planning for capacity in the future, and of course maintaining security on top of that. So focusing on any breaches, infected devices, and of course when there is a trouble, you need to quickly find the root cause of the problem, basically making sure that the time to repair the problem is going to be as lowest as possible. If on top of that, if we look at the trend in the market, we see that public cloud is more and more popular. That doesn't come as a surprise to anyone, I think. And more organizations use now even more. 86% of organizations are using 2 or more public cloud services. So the network is now more and more decentralized, and gaining visibility into different environments is basically hard. You have different monitoring tools, and if you're trying to troubleshoot the issues, you need to basically check 2 or 3 or even more different monitoring tools, and then manually stitch the data together to get some sort of sense of what is going on and trying to mitigate that issues. That, of course, that divided visibility brings security gaps as well. It's much more complex to manage compliance and, of course, associated costs with that. I found an interesting information from EMA, Network Management Megatrends. So every 2 years, the EMA organizations produces Network Megatrends reports. And if you look at the last 3 reports from 2020, 2022, and 2024, we see that network operations tier receive much more alerts that are just noise. So we've become very good at monitoring everything, but providing actual actionable intelligence and being capable of alerting to those, being capable of responding to those issues that actually mean something. That's becoming a bigger and bigger challenge. So let's look a little bit closer. What is the typical downside of network operations? Typically, if you're an IT, network engineer, network administrations, someone calls you, typically a user, complaining about a service unavailability. What do you think? You think is it something have to do with the network? Is it a problem with the server? Is there a problem with the user? You need to figure out where is the issue, and time is running out. So typically, what any IT administrator would do is check their IT infrastructure monitoring. So here in progress, I'm going to referencing IT infrastructure monitoring tool called WhatsApp Gold that we have among our portfolio. But what this provides is your level 1 visibility, I like to call it. You map your whole network, you see number of devices, you monitor performance of each individual devices. But when it comes to actually having a visibility into the traffic, so network traffic analysis, that is what I like to call Flowmon, the next level monitoring. That can tell you where is the root cause. So this is the two products that I'm going to be talking about today mainly, but we're going to be focusing it mainly on Flowmon and network traffic analysis. So with network traffic analysis, we have basically two methods how to provide the visibility. We can either collect full packets, which is basically, well, let's say the best approach. You can basically capture all the data. You're not missing anything. You're having the highest fidelity insight. But there comes associated challenges with storage and scale. So if you have a large enterprise network, it can be very, very pricey to monitor every single packet and manage it and store it and having access to it for several weeks or months. The alternative, lightweight alternative, is the flow data. So monitoring just the flow data will basically provide an easier level. So you're just monitoring the packet headers, understanding who's talking to who, and today with the enrichment of application layers, you can actually have much more visibility into those applications that you need and provide and troubleshoot much more issues. Every time we've had these discussions, you always see you can encounter two camps. One is always for we need full packets, we need full visibility, and the others who understand that basically the light scale approach with flow data is manageable. And that brings us to the myth that I encounter since my last 10 years working with Flowmon and Progress. And that is that flow data doesn't provide sufficient level of details when it comes to network troubleshooting. And you need a full packet to be capable to fully investigate the network issues and fight cybercrime. That was something that we've heard a lot. I would say more and more customers now understand the value of the flow data. So if we look at the graph, we can see that if we imagine communications between client and the server with two different IP addresses, the source and destination IP address, source and destination port number, and protocol is basically the core information we will collect. You can think of it as your, in this analogy, imagine that your phone provider sends you the monthly bill, and on the invoice you also have the detailed list with the phone numbers you've called, when you called them, and how long the conversation lasted. That is the equivalent of the flow data analysis. And packet analysis on top of that would be if you've had, and to each phone call, you would have an attached recording of all that conversations that you had. So maybe you will not be able to understand what you've discussed with a certain phone number on a specific time when you've had that level of detail, but just having that structure every month can give you a basic understanding, how often do you call the office, or where is typically your working hours, and you can derive a lot of interesting information just by having this initial insight. And that is just the basic flow data, but we can actually extend it with the application layer information, as I mentioned. That is the Flowmon approach. So that myth that I described earlier, we actually fight with the reality that the continuous full packet capture tools cannot scale, especially with the enterprise market. And with bandwidth explosion in corporate networks, and companies are switching to flow technologies. And Gartner even noted that for 80% of the network-related issues, the troubleshooting can be solved with NetFlow technology. Here at Flowmon and at Progress Flowmon, we actually trying to go a little bit beyond that statement, and because we are trying to combine the best of both worlds. So you can have the lightweight approach of flow technology and enrich the data with application layer and performance metrics. So you have even deeper insight, and that helps you solve up to 95% of all networking issues. And in addition, with Flowmon, you can actually provide the full packet capture when the flow visibility is not enough. So simply put, if there is an issue, you have the full visibility with the lightweight flow approach. And if you need a deeper insight, you can trigger the full packet capture for those, let's say, mission critical application, and troubleshoot the issues later on with that. Here is a little more detailed comparison of the benefits of the flow approach. So let's imagine that you have 10 gigabits of traffic, and just calculate how much storage would you need to require if you need to capture 1 minute of data, 1 hour of data, and 1 day. So typically, we see that customers would like to have at least 1 month of historical data. For packet capture, 1 month would be 30 times 100 terabytes of data. That's quite a lot. But with the lightweight flow approach, which is in comparison, let's say 500 times more scalable, it only takes a couple of gigabytes. The benefits of Flowmon and the NetFlow technology analysis is that it also can be applicable to encrypted traffic. We know nowadays that most of the internet traffic is encrypted. So how do you will need to unencrypt every single packet, and that's also another challenge with performance and scale. Flowmon and NetFlow technology can provide comparable level of detail with the right metadata enrichment, and it's also suitable for the whole hybrid environment. So cloud, on-prem or hybrid, the level of information is the same, or the depth of visibility. I always like to use this analogy when we're talking about the network monitoring tools. So I mentioned WhatsApp Gold. Typically, it doesn't have to be WhatsApp Gold, but you've got your IT infrastructure monitoring, leveraging the SNMP protocol that gives you your basic mapping of the network and overall performance and memory usage, and just the high level of traffic. The next level is the flow monitoring provided by Flowmon, which I've talked about here. And the biggest approach you can have is the packet analysis. In terms of visibility, it provides you, I like this analogy, you can have a picture drawn by a kid of a zebra. You know it's a zebra, you know it has 4 legs, you know it's got stripes. So that gives you the basic understanding of what the animal looks like. But if you want to have deeper visibility into your network, you can basically imagine that flow monitoring provides you the black and white picture of the real thing. And packet analysis is then what brings you basically the missing colors in the picture. So that is the opening, and let's go a little bit closer into Flowmon specifically. So with Flowmon, it's a network monitoring tool. You can troubleshoot up to 95% of root causes with deep enough visibility, know everything, including hybrid networks, on-prem, cloud, and the blame game between departments. What that specifically means that Flowmon provides visibility not only for network operations team, but anomaly detection for security operations team as well. We'll talk about that a little bit earlier, but there is a security approach as well. And you can, with that visibility, you can actually proactively plan your capacity and your future growth, because we also can provide you historical trends and you can compare how your network is evolving. Oh, there we go. So what does Flowmon look like? What's the architecture? Flowmon, you can think of it as an appliance. The core of the solution is Flowmon Collector, and that appliance can be deployed in virtual environment supporting VMware, Hyper-V, or KVM, or in the major major cloud providers, AWS, Azure, and Google Cloud. So that appliance basically does all the analytics for you and provides you visibility into the network. Where do we get the data from? So for the source of data, we leverage the NetFlow technology. So any format of standard that many of the devices support, from cloud providers, it can be the VPC flow logs. From your typical infrastructure like routers and switches, we can export network telemetry in various formats like NetFlow, IPFix, SFlow, JFlow, NetStream. The Flowmon collector can basically ingest the network telemetry from any sort of devices. On some unusual devices, we might have a problem with tagging, but most of the times we can even work with that. So leverage on an existing infrastructure to get the insight and analyze it with Flowmon collector. Or you can actually leverage the load balancers, which is another product within Progress portfolio, Progress Loadmaster, formerly Camp Loadmaster, and that is also a unique value proposition, because those load balancers are much more closer to the application performance and to the application server, so we can get insight closer to the applications. And of course, firewalls sometimes have also that capability to export NetFlow data. For those instances where we cannot leverage, for whatever reasons, your existing infrastructure, Flowmon Collector actually has a built-in probe capabilities. So we do have a dedicated sensor that we can deploy either as an additional hardware unit, or in terms of virtual deployment, it is inbuilt within Flowmon Collector. And what Flowmon Probe does is that it takes the full copy of the traffic, generates the enriched network metadata. So basically that who's talking to who, how long, using which protocol. And on top of that, we will add application information and provide you that network visibility and troubleshooting capabilities. And we can extend that visibility with additional insights. So I mentioned there is a use case for security operations, and there is our network detection and response capabilities. There is an option to trigger a full packet capture on demand, and there is also additional insight to monitor application performance. All of these three that I just mentioned are in a form of software modules that we just install on the collector and provide the analytics in the UI. And since I mentioned the level 1 monitoring, the IT infrastructure monitoring within WhatsApp Gold, we do have an integrated user interface with Flowmon. So all the key dashboard within Flowmon you can actually monitor within WhatsApp Gold, and basically to avoid the swivel chair management and having one UI to manage all. So that is the architecture. I mentioned the additional value using application layer metadata and headers to provide that visibility into applications. So here is just a example of the scope. So from L1, we monitor MAC addresses, VLAN, MPLS, GRE tunnel, and more. From your layer 3, layer 4 transport layer, it's standard items, who's talking to who, source destination IP addresses, NPM metrics such as round trip time, server response time, retransmission, geolocations, and more. But what's more useful is the application metadata, and that is mainly DNS, DHCP, Samba protocols, specific protocols from SCADA and OT environments, and much more. This is just a small example. So that is why with that deeper visibility, you can actually solve much more network related issues. I mentioned the network performance monitoring, and this is quite important because, like I mentioned in the beginning, like when there is a problem in the server, or when there is a problem with the applications, or whatever the problems may be, as a network administrator, you don't know where the problem is. And typically, many of the organizations who don't have that level of visibility may consider network a black box. And everyone will complain that the network is slow, but it's up to IT administrator to compare, is it really the network that is slow, or is it the server, or is it the application? So excuse me, then brings us to the network performance monitoring principle that Flowmon leverage. We can measure the round trip time, basically the delay introduced by the network. How long does it take to the packet to run through the network? We can measure the server response time. So basically, how long does it take to the server to process and respond to the request? And because we can monitor these individual times, we can provide much more metrics like delays between packets, what's the minimal and maximal delays, what's the average, what's the deviation, as well as monitoring jitter and more. So this alone is very useful metric when it comes to network troubleshooting. So to summarize, network value provided by Flowmon for our hybrid cloud is basically giving you option to decrease reaction time for any types of environments, quickly analyze the root cause, and have on-hand traffic analysis. You're basically reducing the number of tools because you have availability, capacity, troubleshooting, compliance, and forensics, all under one hood within Flowmon. You can automate analytics because with autonomous investigation of root cause of potential issues, this can save you hours and days. With Flowmon, we help you lower network operating costs because you have application performance monitoring, network detection and response, trends forecasting, all of that in one user interface, in one tool. And lastly, we help you end the blame game between departments because you can show responsibility with the proof by having that deep insight. That brings me to one of our customers. This was a healthcare organizations, and what they were dealing with was the MRI scanner occasionally failed to store patients' data. You can imagine this can be a problem because healthcare industry is already under a lot of stress, and I guess that everyone can understand that doctors have much better job to do than doing MRI scans of the same patient for the second time or third time in the row because the scans are not just because the scans aren't saved. What happened in this case? That's the blame game I talked about. Both repository and the scanner suppliers equally blamed the local network. Having that visibility, Flowmon was capable to present the communications between those two systems and proving that the error was with the supplier, which they managed to efficiently remove, after which they efficiently managed to remove the problem. So figuring out the root cause who's responsible and decreasing the mean time, because instead of listening to two suppliers fight, you actually can just come to them with the proof. So this is a really powerful message. But I also mentioned that we have a security operations use case as well. So Flowmon's value is not just for network operations, where we can provide end user experience monitoring, troubleshooting and forensics, forecasting and planning, and monitoring clouds and SaaS performance. But for security operations team, we can actually provide anomaly detection and monitor zero-day attacks, insider threats, analyze encrypted traffic, and basically provide network behavior analysis. You can think of it as a way that Flowmon is like your AI-powered network security analyst that we deliver to you as a software, and that provides you with a powerful detection, so you don't need to monitor your network traffic 24/7 and trying to look for some unusual patterns to recognize an anomaly, but we provide that to you. You have a smart prioritization, so you can quickly understand the change in the trends, change in threat score, and basically quickly know from the first look what is the most urgent thing that you should focus on. We have built-in experience to provide you with recommendations what to do when something is detected, and you can also quickly trigger a response when certain anomalies occur, and block, for example, infected hosts, so you remediate the issues. So now we're moving a little bit into the security. So typically when we talk to our customers, we see that you have your organization secure, you have protection at the perimeter, usually leveraging some firewall, and some agents deployed at the endpoint. That is all and well, but even Gartner says that your detection prevention capabilities are, your detection and response capabilities are more important than your prevention. Because if you're only relying on prevention, what do you do if attackers get past your wall? And attackers knows this. They know that you have some sort of firewall in place. What do you do, and how do you find out? That's more important. How do you find out if someone got past your firewall? And how do you monitor for insider threats, for your users of your network who already have access? What if some of their notebook got infected? So for that, network provides the single source of truth for all communications, because we can monitor not only the traffic that is coming in and out from the internet, but also the lateral movements, basically the east and west traffic, and provide that anomaly detection capabilities, detection and response, and encrypted traffic analysis. So let's just do this slide. So if we look at like the typical examples, what we can detect, it can be dictionary attacks. Someone is trying to break your password, someone using unwanted applications. BitTorrent can be a typical example. Internal security issues in form of viruses, malware, ransomware, botnets, crypto mining, and insider threats. There is a whole wide of scope of what sort of threats can lurk in the network, and how network detection and response capabilities within Flowmon can actually help you detect and respond to those. So the value, you're minimizing the breach impact because you're reducing the gaps in your network, and you can quickly spot any anomalies, the footprints that the attackers leave behind, and stop them from spreading before some major impact happens. You can reduce the number of events because with our smart prioritizations, you only basically respond to what really matters. You can also increase technology staff efficiency because any L1 engineer can master Flowmon within a couple of hours, and with the oversight into network operations and security operations, you're actually helping erase the blame game internally between your department and help them bring them closer together using one tool. So that brings us to responding confidently to incidents and having equalized level of protection for your hybrid cloud networks. This brings me to another example. This comes from an automotive organization. So the manufacturer faced long response times in the production network. IT infrastructure monitoring and firewall tools found traffic accumulation, but not the cause. With the Flowmon deployment, we've immediately indicated that a production server was daily sending gigabytes of raw production logs to headquarters instead of aggregated data, which is not the desired configuration. So quickly figuring out what the root cause is. After some changes in the configuration, the problem is resolved. And another example can be from a wholesale organization. The main ERP server has shown long response times regarding all the operations. So imagine that you come to work and all your systems are basically unresponsive. And this has been going on for 14 days. So quite a serious issue that definitely brings the attention to the management, demanding a quick resolution. Flowmon basically led to a finding that a wrongly configured firewall was constantly loading the ERP server with unnecessary queries. The performance issue has been removed through a simple firewall configuration adjustment. So this is another example. Typically, it doesn't always have to be some attacker, some hacker trying to bring your organizations down, but most of the times it's some operational issues, some misconfiguration, and if you don't have that visibility, it's really hard to figure out and resolve those issues. If you look at it a little bit from a financial standpoint, think of the average cost of a downtime. Based on the IBM and Verizon reports, it's something around $4,500 per minute. If we think of an average duration of a downtime, it's something between 20 to 60 minutes, And now calculate with me. We have an average cost of a 60-minute downtime, $270,000. If you could reduce that 60-minute downtime down to 10 minutes, because you have that visibility, and you're just basically saving $225,000 for a single occurrence of a downtime. That money alone is enough to buy a full scale of Flowmon solution. If we look at it from the security standpoint, the cost of a data breach is estimated to be $4.5 million. If we calculate an example reduction that the detection is immediate or down to 2 hours, you investigate quickly because you have the forensic insight, and you can quickly respond by putting the infected device into the quarantine. Because you stopped the spread much more quickly, you might not end up recover 60 devices, but only 5. And if we think of that, you've basically stopped your average cost of breach from 4.5 million to, let's say, $500,000 with some other associated costs, depending how quickly you stopped the attack. You still saved a lot of money, ensure that your reputation is unintact. So again, in this example, the return of investment of Flowmon is paid by a single security incident. So to summarize, how is Flowmon different? It allows you to scale without compromise. You avoid any blind spots in the network by monitoring everything, not just mission critical applications, because you have the lightweight approach of network telemetry and NetFlow. You're consolidating your tool because you have easy to use solution that integrates a number of use cases, like we mentioned, capacity planning, network performance monitoring, troubleshooting, and threat response into one solution. And with the built-in network detection, we have basically AI and machine learning powered capabilities to spot those threats, those early indicators of compromise, and allowing you a rapid response to mitigate them. So let me go right into the demo, and let me show you some use cases. So let's start with the performance monitoring use case. I have a really nice example here. So what's happening? Let's explore the capabilities of Progress Flowmon and find the root cause of performance degradation. The scenario is that after a system upgrade, you started to experience performance degradations that impacted most of your users and raised management's attention. You use your Progress Camp Load Master load balancer which has confirmed that the application servers are operational, but you lack the proof required to exclude the network's fault. Now the application vendor blames your network. What do you do? So now we are in the LoadMaster user interface. This is just to show you that we can see that both servers that run the applications are 100% up on the LoadMaster side. So we're still missing the proof that the network is not at fault. Here is just an example that I mentioned, that we can also leverage the LoadMaster to export the network telemetry protocol and feed the data to Flowmon. Now we're moving to the Flowmon user interface. So we have our dashboard set up, and we see that our alert was triggered, that is monitoring the server response time for my application. So let's investigate. We can, on a first quick look, see that on these two metrics, which monitors the last 24 hours and the last hour, we can see that the average server response time, basically the time meaning how long does it take to server to process the request, is different. So the last 24-hour average was 6 milliseconds, and in the last hour it's 109. So quite a significant increase. But let's dig a little bit further. We can even map the topology, so we can see that we have the my application that is being accessed by clients, and it's run on the two servers, real server 23 and 24. And we can see that upon comparing those two servers, the server 24 has a much higher average server response time, so 191 millisecond compared to standard 1 millisecond, which is the desired outcome. So let's go explore a little bit deeper. We can see that the average round trip time, so delay introduced by the network, is below 1 millisecond. So there is we can basically, with this, confirm that the network is not at fault, and the real server 24 is responsible. On the timeline and visualization of the traffic, we can see that there is a significant drop. So we know that the problem occurred at 4 o'clock, 4:45 in the afternoon. And if we dig down a little bit further into that specific time frame, we can see, for example, the top 10 metrics and see the top 10 communications. So we see that specifically for the real server 24 and communications between it and LoadMaster, the average server response time was 2 seconds. So the delay is even much more severe. And we can even, with Flowmon, you can drill down into the individual session levels. So we can say, show me the first 20,000 or 10,000 flow communications. And once I get them, I can see actually again that the server response time is much more larger. It's above 3 seconds, and even gives me insight into the application layer metadata. In this example, we can see that there are these get and head requests between the load balancer and the applications. So in this specific example, we are mainly interested in the average server response time, but it's just an example of what sort of level of information we can get with Flowmon. So once we figure out that there is a problem, thanks to Flowmon and its quick root cause analysis, we can basically provide the data to the supplier of the application, and it's up to them to quickly resolve the issue. So you just quickly find the root cause within a couple of clicks, within 5 minutes using Flowmon, and you know where to go next. This is the key value. And so this is for the security use case. And let me go to the security use case. So if we switch into the anomaly detection system, which is the Flowmon ADS module that we have running on the collector, and that basically analyzes the data from security standpoint, we can go through the example of a ransomware scenario. So in this example, sales representative has just returned from a business trip overseas, unaware that their notebook had been infected with malware. Now, back at the office and connecting to the corporate network, they unintentionally let the malware spread. Let's stop the breach from spreading. So we can visualize the data, the traffic on the timeline. We can see different priorities or specific detection methods. And we can see that we have the list of potential anomalies that we should deal with, listed here below with level of severity. Now I'm more interested in this specific upload anomaly. And on the first glance, I can see that there has been one event detected. And I can see that it was at 7 o'clock in the morning. We have our timestamps, and there was a suspicious upload of 22 megabytes of data to this targeted IP address. I can see that this is a blacklisted IP address thanks to the skull icon, and I even see that it's a flag from Thailand. If I go a little bit into the details, so this is the standard full event detail that we provide for each anomaly, and we have what the anomaly it is. We can see the description. We can even see how it relates to MITRE ATT&CK framework. So we know at which stage of the attack we are. So if it's some sort of access or lateral movement, we are at the early stage. If we're at the exfiltration, meaning someone is basically stealing data from our corporate network, we know that we are at the later stage and we should probably respond quickly. So in this case, we can see that this IP address, which is a notebook belonging to Adam Ondra, it's the source who's been responsible to sending the data out of the corporate network. We have a number of different insights available to understand the full forensics, so we can see the individual flow communications, including transfer data, protocol, timestamps, and so on, to have the full evidence. And we can even connect to the signature detection as well. So there is another source, another way how we see that this has been identified as possible bluekeep vulnerability and exploitations through remote desktop protocol. So let's look, we can actually analyze what happened every step of the way. So if we troubleshoot that IP address, and look what other anomalies this has been responsible for, we can see that it's first started scanning some targets. I'm familiar with my network, so I know that these 3 IP addresses on the one ending with 3 is my Windows server is my Windows server, and the one ending with 2 is my Samba server with sensitive information. So we can see that first there was an attempt to break the password. So Samba dictionary attack to that Samba server, which was unsuccessful. Second, I can see there was another password guessing attack to that Windows server, where the attacker was capable of getting through and installed a keylogger into the Windows server. After some time, he was capable of gaining the access to the Samba server, to the Windows server, and laterally move to that Samba server sensitive information. Once he got in, he initiated communication with the known blacklisted command and control server in Thailand, and this was quite a sophisticated way. So the attacker split the data into the smaller chunks, and using ICMP protocol just pinged the data out of the network. So there was one way how we were able to detect that. And also another anomaly, the upload anomaly, was also bigger. This is where we started our investigation. Once the attacker successfully stole your data from your corporate network, the only thing left to do was to encrypt the data on the Samba server and leave a ransom note saying pay X amount of Bitcoins if you want to see your data again, or it will be released to the internet. If you look at the timestamp, we see that the attack started at 7 o'clock and ended in 25 minutes. This is a reconstruction of the actual attack that happened to one of our customers that we reconstructed in our lab. But in reality, it doesn't happen that fast. Usually attackers try to stay unnoticed in the network. So, but using Flowmon, you can actually discover these small footprints. So if, for example, once the infected device is doing some sort of dictionary attacks and trying to break the passwords, this is, of course, an undesired behavior in your network, but thanks to the proactive detection with Flowmon, you can quickly respond, and with one button, you can actually block the Flowmon, block that device in using firewall, for example. So this is the example of the network traffic analysis provided by Flowmon. And I would also like to tell you that you actually have a number of different ways how you can basically get Flowmon. So with our IT infrastructure level monitoring WhatsApp Gold solution, many of our customers who are in the Enterprise Plus tier can actually have access to Flowmon, because within the Enterprise Plus tier, you do have access to NTA Plus capabilities, which is powered by Flowmon. So to those customers, you already have access to those capabilities within. And if you wanna know more about Flowmon, we'll be more than happy to get in touch with you, show you a more detailed demo, what sort of capabilities we have and Flowmon can provide you. And more importantly, you can actually try free Flowmon trial, deploy the solution in your environment, and exactly find out what's going on. Like from network operations standpoint, same way from security operations standpoint. It's all really easy. We can see and deploy Flowmon within 30 minutes. And after the initial configuration, you can immediately see actionable insights, who's talking to who, how long, and what sort of anomalies might be lurking that you're not aware of. So we've come at the end of our webinar. So let's move to the questions. So let me see if I can see the question panel. We're running a little bit out of time, so let's just cover a couple of questions. I see there is one question. Can you monitor cloud VPC flow logs? Yes. So if I go back to the architecture slide, yeah. So like I mentioned, we can. This is actually one of our differentiators, because I'm not aware of any vendor that is capable of leveraging the the cloud flow logs from all these three cloud providers, from AWS, Azure, and Google Cloud. We can monitor their native flow logs. There is a added value, because if you cannot monitor the flow logs, you would need to deploy a Flowmon probe, mirror the full traffic, and of course, cloud platforms basically will charge you for the amount of data that you transfer. So with the network telemetry being 500 times more scalable than the full packets, you're basically saving a lot of money. I think we even have a blog post where I calculated the differences, and it was like 10x difference in the cost if you leverage the cloud flow logs. I see there is another questions. The NTA Plus in WhatsApp Gold Enterprise Plus, is it Flowmon collector? Does it come with Flowmon probe? Yes. So for in the Enterprise Plus tier, the NTA Plus capability is the collector that is powered by Flowmon, and you do have option to actually extend it with the probe capabilities. So the NTA Plus gives you like the first step into the network traffic analysis world, which is powered by Flowmon in the form of only a collector, but you can actually extend it with the probe and with the network traffic detection and response module, packet capture, and application performance monitoring. So basically we've added the NTA Plus feature into the NTA Plus tier to give our WhatsApp Gold customers the glimpse of the capabilities that Flowmon provides, and basically help them solve more and more use cases using that advanced traffic analysis. So this is the easiest way how our WhatsApp Gold customers can do that. I see there is another question. Does the Flowmon collector virtual appliance handle less load than physical appliance? How do we determine when to use virtual and physical appliance? The easiest way is to compare our data sheets. So if I go to our website, we do have monitored or we do have described the Flowmon collector in the bottom. And if you look at the collector model specification, we can compare the hardware appliances and their performances compared to those of virtual. So of course, we always recommend hardware because this is what is tested by us as a vendor, and we can basically stand by those metrics. With virtual appliances, it always depends how much resources you assign to the into that virtual machine. So there is that difference. Okay. I see that there are no more questions coming in. So again, I would encourage you, if you have any questions, don't hesitate to reach out to us. We'll be more than happy to start the conversation with you and show you Flowmon, whether it is within WhatsApp Gold and NTA Plus or standalone product, how it can help you solve your issues. And with that, I thank you for your attention, and see you on the next webinar. Thank you. Goodbye.